My 9-year-old son asked me to help him build a Scribblebot. Alright, let's do that thing. A Scribblebot, for those who are not aware, is, well, it's not really a robot at all. It's just kind of a robot adjacent project that you can do. You basically tape onto a plastic cup or something a couple of pens and markers. You tape them around in different directions so that these kind of become the inky legs of your robot. Then you put a motor on top, but you make sure that that motor is somehow imbalanced severely. Run some power to it somehow, put a battery in there, right? And then the Scribblebot will shake and shimmy around at its various legs, squiggle around and draw scribbles on a piece of paper. See? Easy. I've got a big box of electronics components that I've scavenged over the years to, use for this exact sort of project. I've got multimeter and stuff for soldering, papers, transistors. I ought to figure out what that does one day. Let's see, LEDs and power supplies. I think this box is the one with the components that we really want in it. Here we go. We can put a switch on this one. We got a button right there that we can use for a switch. We've got a couple of choices of motors that we can use. What we really need is a battery, and that's not enough power for some of these motors. And there we go, battery case. So we got the battery, we got the motor, we got the switch. And as good a switch as this is, I know for a fact that I have a switch with an LED inside of it at the makerspace. So I think we'll put that switch back and we'll use that one at the makerspace. However, with the LED in it, that actually creates a new problem for this. Theoretically, the process of having a switch in here and then using that to power both the motor and the LED is theoretically a very simple idea. You just wire them up in parallel. However, the complication comes because the switch in physical reality and the LED are pretty much occupying the exact same space. And so what we need to do is have that power that's coming out of the switch basically go back into the switch and then come back out to, not ground, I don't know, is it ground when it's on a direct current system? The negative side, the outgoing, regardless, our circuit diagram is going to end up looking a little bit more like this in reality, and that's going to be complicated. Why was this so difficult to figure out? These connections back here were a pain in the neck because I have to wire the LED that's inside the button in parallel with the motor, so it's got to feed back in on itself. Minimalist connections. I really kind of hacked this together, but it works now. I push the button and the motor spins and the light lights up. So, success. I've been thinking about this project a little bit, and so that it's not just me staring at the camera while you guys just sit and listen to me, why don't you guys play a little game that I like to call Find the Artwork in the Park. Oh, you're really good at this. 1 point already. Fantastic. So, a Wigglebot is a project that I've heard of. Of course I've heard of it. And I know of its existence, but I never felt motivated to actually do it. Not because I didn't think I could. The exact opposite. I was like, of course I can make a Wigglebot. That's too easy. Give me a challenge. Give me something to work on. So I didn't do it because I thought it was too easy. And yet, even in this easy project, there has been
its own little challenges. And so I feel like I've grown and I've gotten better as I've challenged myself to do this simple little project. Did you catch that point? Good. Now, there are other projects that are more difficult, working with Arduinos and things like that. And generally speaking, those projects kind of scare me. Not to say they scare me, but I just have a hard time getting up and running in those projects. And I wonder, as I've been thinking about this, I think I lack confidence. The thing is, if you lack confidence about doing something, the best way to gain that confidence, and an extra point, the best way to gain that confidence is to do projects that you know that you'll be able to succeed at. Success builds confidence. And so I really should have, before this point, made a Wigglebot. I should have done all kinds of dumb little projects that I just kind of poo-pooed away because they would have built my confidence, and maybe I would already be on the bigger, harder projects if I had done that. Of course, my son doesn't have that problem. He's already starting in the right place. He sees a simple project and he says, I want to do it. For him, these projects are challenging. They are at his skill level. They're the projects that are going to build his confidence so that when he gets to my point, there won't be anything that he's not ready to do. He'll be unafraid, unabashed, and strong at it. And so maybe I've undercut myself. Maybe the lesson in this whole thing is do the dumb projects. Do the ones that you think are below you, because that'll give you the confidence to do bigger projects. Post your final score for Spot the Artwork in the Park in the comments below.
Of course, I'm the 3D printing professor. I'm not going to use any plastic cup with this. We're going to 3D print the body for this particular project. And with the first iteration, I thought I was going to be really clever. Now, if you take a look at what I designed for the first iteration of this, it's a solid object, but it's got holes in it where the pens are going to go. But you say, shouldn't this be wide open? Shouldn't this be so that you can, fill it with the electronics and stuff that you need? Aha, yes, of course. With a couple of choice settings changed, for instance, thickening up the walls, 0 infill, and no top thickness, theoretically, I could take that shape and turn it into more or less the shape that I want right here. It'll allow me to have a big open surface on the inside where I could stuff with wires and electronics and whatever I want. I'm going to have to melt a hole in the side to put the button in, but that's no big deal. However, when I tried to do this, the print came out not good. See, whenever you print with 0% infill, the slicer still treats the travel distance inside as infill travel distance. It doesn't retract, and you end up with stringies all over the place. Now, I could have cleaned that up and used that, but then there was still the problem of drilling the hole in the side. I just decided to go back to Tinkercad and make the shape that I wanted in the first. So here we are in Tinkercad, and here's the shape as I want it. It's got a couple of holes in the top so that I can mount the motor up top and drop the wires into it. And inside here I've got this is the size of the 4 battery pack that I'm going to be using. I just wanted to make sure that it could fit inside there, but I didn't want to strap it to the outside. I wanted it to be close to the middle so that it doesn't imbalance things, and I think with a little bit of hot glue we'll be able to make that work. And of course there's the big button hole in the front that is perfectly measured so we can slide the button in there. I think we got our design. I think we got the 3D print for this, so let's 3D print this off and finish working on the components. I want to try and take these components and put leads on them that are long enough so that all my son really has to do is I'll have him strip the wires, but then twist the leads together and then cover them with a little bit of electrical tape so that it's really easy for him to just make those connections, tape them up so that they're safe, and then he'll have his working bot.
So I'm working on the electronic components for the Scribblebot, and I've got them all hooked up the way they need to. There's a loose connection in there. And I came up with a really clever idea. The hard part of this connection is that because there's an LED in the button, the outgoing power needs to go back into the button and come out in the right direction. But once I got it all together, I realized it was pretty simple. I just need these 3 wires to be just spliced together, these 3 wires to be spliced together, and then these 2. So to take this all apart and take it home and have my son build it and put it together, I came up with a great idea for keeping them together. Duct tape! No, I'm not going to duct tape them. Here's what I'm going to do. Like this one, I'm going to put a little bit of gray duct tape around this wire and this wire and this wire. I'm going to put a little orange or green duct tape around these 3, and then green or orange, whichever one's left, around these 2, so that all I have to tell them is just twist the ends of the gray ones together and the green ones together and the orange ones together, and it will just work. So hopefully that will enable him to get this going as easily as possible and help me keep it straight in the future. I printed the Wigglebot part on the Cube 2 3D printer sent to me by my friends from Longer 3D Printers. Now, this is a mini 3D printer and it retails for about $200, so it is probably closest to compare it to the Monoprice Select Mini, which I have strong feelings about the Monoprice Select Mini and a history with them. They're great printers. So how does this printer measure up? Well, I'll tell you the truth, there was a lot of back and forth with this printer. For instance, it's got a removable build plate, and that's good, but it's not a heated build plate. Its build area is a little bit bigger than the Monoprice Select Mini, but it doesn't have any filament holder. They give you this external filament holder, but that just seems cumbersome. I'd like something attached to the side of the machine. It's got a great and beautiful touchscreen on here, but the SD card for it is in the back, which means that you need to have the front of it open so that you can hit the touchscreen, the side of it open so that you can put filament next to it, and the back of it open so that you can reach and get the SD card. It's got an enclosure, that's good. It keeps out the wind and environmental elements mostly. It's still fairly open, and yet for as open as it is, I had a hard time getting my big old man hands in there to level the build plate. So like I said, a lot of back and forth. It felt like for every plus I was giving this, it was taking a minus back from me. Now the first thing I printed was one of these test prints. Cute little owls, absolutely love them. But it was a test print. It was a print on their SD card, so I wanted to be able to load up my own slicer and load up my own settings. And this machine isn't in Cura, so I had to set up the settings carefully. And the first print that I printed from it came out... What the heck? Oh, wait a second. I know what's happening here. Cura likes to set its default filament diameter at 2.85, and this has a filament diameter of 1.75, which means it wasn't putting out enough filament. Be careful with your settings when you're doing things in Cura. Once I got that set up, it printed just fine, and in PLA it was doing great. In fact, I printed some of my Chibi Malls in some Filablend that I have so that they change color as you turn them around, which I think is kind of neat, and it handled that. But what about other filaments? Could it do PETG? I pulled up some of the Fiberology Burgundy PETG from my friends at Wolf 3D, threw it in there, and it handled it like a champ. I had some Sunlu wood filament, and I printed some more supporter tiles for people who would back my low poly dyno Kickstarter. Finally getting around to printing some of those. Chris Taylor, Nere's, there's yours. Yakov G, there's yours. And Aaron and Gracie, here is yours. I'll get those on the wall soon. So over and over again, this machine was impressing me from an output standpoint, but still it had a lot of weird little things. But then I started to have some problems. Not problems with the printer. My filament broke. And when that filament snapped off, it stopped the print, paused it, and said, "Your filament's out, change it." And it was so easy to change the filament. It caught it soon enough, and I was like, that's pretty impressive. Okay, I'll use this printer to print my son's Wigglebot with. So I started to print, left, came back the next day, and the print was only half finished and stopped. Apparently, I had had a power outage in the middle of the night, and the print was a loss. except that it wasn't. The menu on front was saying, we had a power outage. Do you want me to continue the print? And I went, sure, and hit go on it, and it finished the print. And this printer managed to recover from a failed print. A $200 3D printer with lost print recovery. All of a sudden, I'm a believer. I honestly think this printer has moved itself to the top of the list and might very well be my #1 recommended 3D printer for $200. Yes, having the SD card on the back and the touchscreen on the front is frustrating, but you could actually fix it. I'm looking at this and thinking, well, take out a couple of screws. I'll have to move the extruder motor for a little while, and then I'll take that and I'll mount it on the back and just turn the machine around. It'll be kind of weird having the power going in through the front now, but at least I'll be able to get at the SD card easily. And that's a simple modification. I think the cable's long enough. It should be able to do it. I'll get back to you guys on whether that was a good idea, but I can't fault it for having a modification that you have to do before it hits full potential, because it's the same thing with the Monoprice Select Mini. Their build plates go out after a little while. You have to fix them. So all in all, I may have to admit that this printer has really impressed me, and I think you should check it out.
Then you jump it, pull it. It's kind of hard, huh? Which one were you doing it on, the first or the second one?
The first. Oh, look at the. How? There's the tools.
Very good. Good.
Like that.
Like that.
Beep, 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 beep. Beep.
Very good. Either one. Oh no. Oh, crud.
What's happening?
Oh, the wire fell off. I need to re-solder this one. I've got a soldering iron. No, tape won't work for this one.
Just in case if anybody gets hurt.
Okay, that is done. Just to keep that wire down, and a dab of hot glue on. You're going to run the hot glue then? Now put a big dollop on the bottom here.
Why is it so hot?
The hot glue gun being hot, doesn't that just beat all? So that you don't burn your finger. Can you hold that like that? Okay, put that down right into the glue. Like this.
That's how you do it.
That's how you do it. Listen good.
It's really hot. Here's a joke. But what did the people say when the robot died? Answer is...
Rust and grease.
Yeah. Oh, it's
All right.
funny.
We had some trouble assembling it. As always, that sort of thing, you never know what you're going to run into until you actually do it. The wires that we were stripping for the battery pack were so thin and frail, they kept breaking and we had to cut them further and further and further back. But my boy here did finally strip his own wire by himself. That was a lot of fun. Who knew that wire stripping was so difficult?
Wow, look at this.
You did it! Yay!
And then we got them all twisted. We put a little bit of electrical tape on there. And then I got all my connections right. It fires up and it goes and it works. So now we are going to put the markers in there. We're going to hold them in with a little bit of blue tack, simple solution. And then we're going to take this thing for a test drive. Squish it in there good. I wonder if we're going to have one of these be too tall or one of these be too short. Let's find out. And push the button. Here it goes. How cool is that?
Wow. Wow. That is a cool thing.
It's not stopping! No, the button is stuck. How did we break the button? All right.
Oh, you jammed it too hard.
Well, what do you think of the first piece of artwork of your Scribblebot?
Anyways, it's pretty good.
There we go. What did you think of making your first robot?
Cool.
Yeah, he's a great robot, isn't he? Okay, well, thank you guys very much. This was a great project for me. I enjoyed it. So thank you for making me do this project. It was really cool. Let's go get a piece of paper and do another one, okay?
Bye now.
Yeah. All right. Yeah. Thank you very much for watching. Hey, if I mentioned anything in this video, you'll find a link to it in the cards, and you should check that out. Did you know that I'm social? I've got links to all the socials, and you should stop by and say hi. I really kind of enjoy it when that happens. Big thanks go out to my direct backers, and if you want to know more about how you can become that, there'll be a link right here that you can check out. And as always, I want to remind you, safety first, because I care about you. And I'll see you next time. Oh, that's interesting. Classic one there.